In this lecture, we'll be discussing about the types of motion and we'll try to understand what are the parameters in those types of motion. So in engineering mechanics, as we have discussed in the earlier lecture, that motion is defined with the help of displacement, which is related to position, then velocity and acceleration, and we have seen how these parameters are calculated. So based on these three parameters, we have two basic types of motion. One is rectilinear motion. And second, we have curvilinear motion. So when I say rectilinear or curvilinear, what does that mean is, suppose if I am considering the rectilinear motion, the meaning of this is the object will be in motion in straight line. What does that mean is, the object will be either traveling any of the direction, but it will be traveling in the straight line only. So either it is going upward, downward, or it is going in the inclined direction. It will be moving in the straight line only. So it is not going to change its direction. Direction will be one directional or single directional object. So the object will be in motion in one line only. This particular motion is called as rectilinear motion. So when I say a rectilinear motion, it is generally particle is moving along a straight line. It's called as a rectilinear motion. But when I say a curvilinear motion, in this case the object or the particle will be moving in a curved path like this, or it may be moving in a circular path, or it may be moving in a parabolic path. So in any of these conditions, the object is not going in a straight line, or in other words, when I say the motion is changing with respect to x and y axis at every particular point of time, that is called as curvilinear motion. So when I say curvilinear motion, it is moving, the object or the particle is moving in a curved path. So it may be irregular curved path like this. It may be a circular motion where you have a defined radius, or you may be having a parabolic. So in any of the conditions, the object is moving in a curvilinear path. So the particle which is moving in a curvilinear path, or which is moving in a curved path, that particular motion is called as curvilinear motion. So in this particular syllabus, initially we'll be dealing with rectilinear motion, and then we'll be dealing with curvilinear motion. So we'll try to understand what is rectilinear motion and what are the effects of those. So before going into the rectilinear motion, we'll try to understand there are two basic branches of dynamics which help us to understand the rectilinear motion. So there are two parts of dynamics which are basically required for our understanding. One is kinematics and another one is kinetics. And these two branches of dynamics are governed by a fundamental equation of Newton's second law, which is summation of F equals to ma. So based on these two conditions, based on this equation, these two branches are defined. So first we'll try to understand what is kinematics, and then we'll try to understand what is kinetics. So when I say kinematics, kinematics is generally study of motion without a reference to the forces which cause the motion. So first we try to understand the definition, then we try to understand the effect of that. So it is the study of motion without the reference of forces causing the motion. What does that mean is, when I consider the definition with respect to Newton's second law, if I write this as summation of F equals to ma, any object which is subjected to any kind of forces, this is the summation of forces, that might be number of forces acting on this object. So because of these forces, the object is going to move in this direction with certain velocity and certain acceleration. Now when I am considering only the acceleration or velocity part of it, I am considering only the right hand side of the part of the equation. That means I am not considering the summation f part of this equation. I am considering only f into a. Now again, since the mass is constant, you don't have to calculate the mass parameter of this, because we are considering only the particles, and the mass is constant. We are not interested in the mass of the object. So what we are interested in, we are interested in the acceleration part of it. So when I say we are interested in the acceleration part of it, acceleration again deals with the velocity, the displacement and the position. That means, and the time period. So I am interested only these four parameters when I am considering the part of kinematics. So I am not interested in the forces. So what kind of forces acting, or how many forces are acting, in which direction they are acting, I am not interested. I am interested only in the effect of the forces. So after the application of forces, what will be the displacement, what will be the position, what will be the velocity, what is the acceleration, and what is the time period. These parameters are required for the understanding of the motion, and that is called as the kinematics. So kinematics generally defined as, it is the study of geometry of the motion. Why it is called as geometry of the motion? Suppose the object is moving from one point to another point, and since we are dealing with the rectilinear motion, I am considering only the straight line motion here. So it is going from A to B. So I am interested in what is the velocity position at this point. I am interested in what is the displacement at this point. I am interested in only velocity and acceleration. So at every particular point of time, I am interested only in these four parameters. So if I know the parameters of this, I can find out the geometry of the motion. So at what time, where it will be, what will be the velocity, what will be the acceleration, likewise. So it is only the study of geometry of the motion. It can be used in the curvilinear motion as well. So if I suppose take this as the x-axis, and if the object is moving like this, so at any particular point of time, again I should be able to find out these four parameters, that is the position, displacement, velocity and acceleration with respect to time period. Here also with respect to time period. So if I can find out the four parameters at any particular point of time, I can say that I know the geometry of the motion. So we are interested only in the geometry of the motion and not in the forces causing the motion. So we are not interested in the force causing the motion. As we know that Newton's first law says that any object will not change its state until and unless force is applied. That means if I have an object, if it is at rest, it will be at rest until and unless if I apply the force, it is not going to change its state. So it is going to move. But if it is moving, then it will either move faster or it will move slower or it will stop. So only because of the forces the object will be in motion, but we are not interested in the motion in this case. In case of kinetics, we have to consider the forces as well as the effect of the forces. So in the kinetics, we are considering the forces causing the motion and the effect of the force. What does that mean is, if I consider the Newton's second law, means that I am considering the summation of F as well and the acceleration as well. That means I have to use the resolution and composition of forces in this case, because we need to find out the resultant. And here I have to use the basics of mechanics to find out the velocity, displacement, position, as well as the time period. So in this particular case, we are considering the forces acting on the object and their resulting motions, right? So when I study the kinetics, it is the study of relation existing between the forces acting on the body and the motion of the body. As we have seen, so forces acting on the body is summation of F, and the object is going to have a mass, so m, and their motion of the body is acceleration. So we are going to deal with this particular part. So kinetics is generally used to predict the forces caused by the motion. So it is generally used, which is very, very important. It is used to predict the motion caused by the forces or the forces causing the motion. What does that mean is, either the forces will be given to you and they will ask you to calculate the acceleration or related parameters, that is velocity, displacement, time period, and the position. Or in other case, they will give you the values of acceleration and they will ask you to calculate the forces. So either this is known to you and you have to calculate these parameters, or this is given to you and you will be asked to calculate the forces. So in both the cases, we are going to make use of kinetics. So this is the basic branch of, or you can say parts of dynamics. One is kinematic and another one is kinetic. So kinematics deals with only with respect to the geometry of the motion, and kinetic deals with the forces and their effects on the object, right? So in the next lecture, we'll be dealing with kinematic of the object or a particle when it is subjected to forces and how we have to calculate it related to rectilinear motion.